Hi guys, in this video we're going to have a look at how we can find sets of values of x for different inequalities. So now when I said of x, it's only because we're using x in the question. If it was k in the question, we'd be saying values of k. Now you should have seen this before, and basically you have letters and numbers with an inequality sign which we can treat exactly the same as an equal sign, because equations and inequalities pretty much are exactly the same thing. Inequalities has an infinite amount of answers, and an equation typically only has one. So we're going to solve it basically the same way. So here we have two unknowns, one on each side, and this is the one on the right is the smallest, so that's what we're going to get rid of. So you should be able to say it's 3x plus 6 is less than 21. Keep going when you're solving, and we would have x is less than 5. And there you go. They are the set of values of x that obey this. So any number that's less than 5. Now let's try a different one. This one's a really interesting one because it looks much easier. What I'm going to do is it just looks much easier, but it isn't. It can be quite tricky, and there's a little trick that you need to be aware of. So what I'm going to do is, there's no x's here, but because this is a negative 3 on the left, I'm going to plus 3x to both sides. So I would have that. Now, obviously I want to get x on its own, so I'm going to subtract this 30, which would give me minus 18. And therefore, to get 1x, I'm dividing by 3, and I get minus 6. Now, if you think of a number here, because most people don't like writing the inequalities like this, they much prefer it this way. But if you think of a number like 0, minus 6 is less than or equal to 0. If I keep this like that and put minus 6, what I'm now saying that 0 is less than or equal to minus 6. That doesn't make any sense. So what we have to remember is, if we're going to swap at the end, like I just have, you also have to swap your inequality sign or change its direction. And it's dead easy to remember because you just put a number in there and just make sure that the same situation works. Now let me write this one again, because if I kept the x term where it is and subtract this, I would get minus 3x is less than 18. Now, if I'm going to divide by minus 3, I have to remember this same little trick here. Dividing by a minus number, we change the direction of our inequality sign. Because if we don't, you'll see we get the completely wrong answer. So that's a very good question to understand. So we can make it slightly harder by putting brackets in, but it really isn't any different. So we just go ahead, expand our brackets. This has got the most x's, so we'll collect them there. That means I have to get rid of this, so I'm going to do that all in one go. And therefore I'm dividing by 4, so it's minus 31 over 4. Or you can say that is minus 7. 7 fours are 28, minus 7 3 quarters. Okay, so it's solving equations basically. But it gets more interesting when we find the values that meet this criteria and another one. So let's go ahead and solve this one. So we're going to have 2x is less than 16, x is less than 8. So the values for the one on the left is anything less than 8. Here we're going to have 2x is more than minus 4, so x is more than minus 2. So the easiest way to do this is, if you think of a number line, I'm going to just try and draw it a little bit more horizontal than that. There we go. So here we've got 8, and we also need minus 2. So this first one here, x is less than 8, where we say, well, it's all of these numbers here. And this one on the right, where x is more than minus 2, well, it's all of those numbers there. So find a set of values that works for this one on the left and the one on the right. You should be able to see, just get my highlighter out, it's all of these numbers in this area here. So what we can say, the numbers have to be less than 8 but more than minus 2. That will work for both of them. Let's try another one. So do exactly the same process. So that's going to be 5x is more than 17. So x is more than 17 over 5, or 3 2/5. Okay, we collect the x's on this side. So we're going to have 4x. So we're getting rid of this 4. So take away 4, we get 8. So we'd have this. And remember, if I want to swap it round, I change the direction of my inequality sign. So let's draw a number line. So we have, let's just say 2, and that's 3 2/5. So we know on this one on the left, they have to be more than that. The one on the right says they have to be more than 2. So you can see for both of these, what we actually have is we have this area here. So all of these numbers here meet the criteria for both. So what we can say is x must be more than 3 2/5. That will always work for both. Let's try one more. So here we have exactly the same, so let's solve it. So collect the x's on the left and the numbers on the right. So x is going to be more than 2. X is on the left for this one, so it'll be 3x is more than 12. So x is more than 4. So this is going to be exactly the same scenario as the other one. So let's say there's 2. Let's say there's 4. The first one has to be more than 2. And this one has to be more than 4. So we're looking at this area here for both. So x has to be more than 4. Now, I haven't got a question ready that would give you this scenario, but sometimes, let's say that's 3, and let's say that's 1, and you've solved it, and you've got this. So they must be more than 3. And you've also got this, saying the numbers must be less than 1. So we'll have an inequality there and an inequality there. So what set of values of x satisfy this one and this one? And you can see that there is at all no overlap. So the numbers are actually well, there isn't any basically, because there's no overlap. So we just say no values. So if you end up with your picture like this, that's fine. It's natural to think, well, you've made a mistake because they're asking for the set of values. But what we expect you to say, there are no set of values. Okay, that's it.